Welcome back. And next up is Tuofu from Semtech. Enjoy his talk.
Hello, I'm Matt Hatton, founding partner at Transformer Insights. I've been doing some guest interviewing for the Things conference, and I'm delighted to have with me Tuofu Liu from Semtech. Tuofu, welcome.
Oh, thanks for inviting me, Matt.
My pleasure. We're going to be talking about low-cost gateways, but first off, a few words of introduction about yourself, who you are, where you're from, what your role is within Semtech, if you wouldn't mind.
Yeah, I'm Tuofu. I joined Semtech in June last year. So I'm responsible for LoRa-based products, and I'm based in San Jose, California.
Excellent. Okay, so the focus of this particular conversation is going to be on a couple of new product launches that Semtech's had. The SX1302 and SX1303 low-cost gateway reference designs, if I understand correctly. So if we're talking about low-cost gateways, what's the benefit of a low-cost gateway?
Yeah, the benefits of low-cost gateway is to enable a lot of new use cases. For example, smart homes, smart factory, smart store, and smart buildings. So, so these gateways, because of the lower cost, that will enable these new use cases to enjoy significant growth.
Okay.
And yeah, so that these low-cost gateway, it's very similar to a previous gateway, but it has a lower power consumption and a lower solution area as well. So that's in addition to low cost.
Okay, so the thinking is if you can bring that price down, you can open up a much bigger market to be addressed in all sorts of more price sensitive pieces of the market, I guess is the thinking. Okay, good. Yeah. So what is it that makes these products, the 1302 and 1303 gateways, low cost? How do you do it? How do you make a low cost gateway?
Yeah, so the 1302, 1303 gateway chip compare with the previous legacy gateway chip. One is a much lower power consumption, so that actually eliminate some of the thermal heating components in the gateway design. So that's one aspect of reducing cost. The other aspect is these chips has a smaller footprint and a smaller chipset package as well, potentially enable smaller size of solution. So that potentially also reduce the cost. The solution size, reference solution size gets reduced as well. And also the chip was designed in a way that the external R-bond components also gets reduced. So the R-bond components get reduced, but it also reduced the price of the reference design. So combine all these three aspects, that's how it reduced overall gateway price.
Okay.
Cost. Yeah.
Okay. And can you give me a sort of order of magnitude idea about how much it's reducing the costs by, just to get an idea? Is it 90%, 50%, 20%? What are we talking?
Yeah. So with these cost reduction, we are enabling, for example, $50 to $70 gateways, which is compared to previous gateway hundreds of dollars. So that's quite a lot of reduction actually. Yeah.
Okay, that's interesting. So tell me about the features of these gateways that you're introducing. I think we've sort of touched on some of them, but if you can run me through the features of the gateway to understand what it is that they're delivering.
Yeah. So for 1302, 1303 reference designs, during the past 6 months, we launched 4 new features. So the first feature is called Fine Timestamp. It's on the 1303 we call core cell reference design. So, find timestamp means, so let me give you an example. So when a LoRa device transmits a packet, that packet can be received by multiple gateways nearby.
Mm-hmm.
However, each gateway receives that packet at different times based on the distance between the gateway and that LoRa device. So if a gateway is closer to the LoRa device, it receives that packet earlier. Another gateway which is farther will receive the same packet at a later time. So based on this time difference of arrival, we can calculate the location of that LoRa device.
Mm-hmm.
So it's called TDOA, so network centric geolocation. So basically,
effectively triangulation by signal strength. Yes. Okay. That makes sense.
not by packet arrival time.
Sorry, packet arrival time rather. Yes.
Yeah.
So it has been done in other technologies with signal strength, but yes, I see your point. Arrival time. Yep. Very good.
So in our 1303 chip, inside our chip hardware, we have the capability of timestamp of each receiving packet. So that's why on our 1303 based core cell reference design, each gateway can timestamp each packet that it receives. Then based on this time difference of arrival, the same packet arriving at a different gateway at different times, so we can calculate the location of the device. So basically, this is kind of also kind of a geolocation service, but without using a GPS chip on the device side. So it's a very low cost solution for geolocation. And basically on the end node device, you don't need to do anything. You don't need to add any GPS chip. And
also works in building as well, presumably. So you don't even need line of sight to a satellite. You might not need line of sight to a satellite anyway in certain circumstances, but presumably this doesn't need line of sight.
Yeah, ideally it works outside, but so basically it also needs a time synchronization signal. So on the reference design, you need a GPS chip on the gateway, you need a GPS chip to sync time among different gateways.
Okay.
So yeah, inside the building, it's difficult to get that source. But so it's ideally outside to tracking devices outside.
Okay.
And so the accuracy for this network-centric geolocation is compared to a GPS chip is different. So accuracy is about 75 to 150 meters. There are a lot of use cases that does not need a GPS chip type of accuracy, like for example, certain asset tracking. If you want to track a big truck, and accuracy of 75 to 150 meters probably is good enough. Yeah. So there are a lot of use cases with these network geolocation. So geolocation tracking is can use this TDOA with a fine timestamp feature. So this is a very low cost feature. As I mentioned, it does not need to add any GPS chip on the end devices.
Very good. And other features you mentioned there were 4.
Yeah, the second feature is called the listen before talk. It's on our 1302 core cell reference design. So right now, when a gateway wants to send a packet, it can send packet at any time without looking at the traffic condition in the air. So the problem with this approach is that packet could potentially collide with other packets already in the air from other LoRa devices. So listen before talk basically for gateway to listen first before it transmit packet. It listen to the channel conditions to see whether there are already other LoRa packets in the air by other LoRa devices. So if the channel is clean, then it transmit that packet. So basically, it looking over traffic first. If there's no traffic, it transmit the packet. So that potentially can reduce packet collision in the air and making the whole communication system more efficient.
Okay, but is there a power penalty associated with that for listening before transmitting? Presumably there's a small one, but then it's counteracted, mitigated by the fact that you maybe you don't need to send as often or whatever.
Yes, so on the gateway side, the gateway normally is connected to a power source.
Of course,
and,
of course.
Yeah,
so
yeah,
not
yeah.
such a big deal.
Yeah. So we using a separate chip, LoRa chip for listening purposes. So while listening, gateway can continue perform, receiving data and doing regular communications. So that device, a separate LoRa chip, doing the listening, and when it detects the channels clean, it let the gateway know. Gateway can let our 1302 chip know, and our 1302 chip can start transmit a packet. So that's called listen before talk.
Brilliant.
Yeah. The third feature is called spectral scan. Spectral scan basically for gateway, it scanning the whole frequency spectrum and to identify for certain frequency how congested there are. So whether there's a congestion on certain frequency or less congestion on other frequencies. So basically this allow user or operators to find a less congested frequency to use to enable better channel planning. So it's called a spectral scan.
And will it use that dynamically, or is that something for more long-term planning?
It can be so if you install a gateway, our 1302 Corsair gateway, that feature is already there. You can use anytime you want. Anytime you can enable that feature.
Okay.
If you want to look at the spectrum traffic in the spectrum.
Okay, great. And the fourth and final feature?
Yeah, the fourth final feature we call the full duplex. It's implemented on our 1302 Corsair gateway. Right now, it's for the China region. So right now, gateway are half duplex mode. Basically means when you receive, you cannot transmit. When you transmit, you cannot receive. So full duplex means the gateway can transmit and receive at the same time.
Okay.
So that actually has a lot of benefits to that. So one benefit is when you have receiving a lot of packets. So right now the gateway will wait after receiving all these packets, then you can transmit. So with the full duplex feature, you don't have to wait. You can transmit while you are receiving. It also improves the communication network efficiency as well. And also there's a use cases that when you have, for example, a smart office or a smart building, when a solution provider provide a company LoRaWAN networks inside their building, they can potentially deploy multiple gateways. So when you have multiple gateways, one gateway can receiving, the other gateway can transmit. It's kind of already performing full duplex functionality. However, there are many cases when a solution provider provide a service, provide a solution to us to an office, that company may not allow you to use their internal network to sending data out for privacy or for security purposes. So the solution provider has to using a cellular backhaul to send the data out. So in this case, if you employ multiple gateways, it's very expensive because you pay cellular fees monthly. So in that case, when you have a full duplex solution, you will be able to, transmit the receiver at the same time without using multiple gateways to perform that functionality.
Okay, great. Hey, Tuofu, this has been brilliant. We're out of time, I'm afraid. I just want to say thank you for sharing about your new products, and say thank you very much.
Yeah, thank you. Thank you for inviting me.